Assalamu alaikum warahmatullahi wabarakatuh. This is Ahmed Hegazy. Today, inshallah, in this tutorial, we will learn how to make a lifting simulation for this horizontal vessel by that way and make a rendering video for that. We will use SEG software for equipment modeling, and we will use SEG helper software for the cranes and shackles, the truck. And all files will be uploaded, and you will find the download link on the description of this video. Here, as you can figure, we generate the 3D model for all those items, and we will make sub-assemblies. And on the next minutes, we will generate the assembly. From here, we will open a new standard assembly, and we will import the project items. From here, we will import the Mantok crane, and we will import it by that way. And you can make constraints by using the flush constraint by making a flush for the origin planes by that way. Okay. Or you can import the assembly of the crane by another way, which is grounded. So let's import it as grounded. So during importing, you can select it as grounded. You can figure that on the tree, it's grounded. So you have the two ways. Now we will import the truck, the transportation truck, and we will make some constraints for this truck. The first, we will make it blend on the ground level. So we will select the level of the ground level and make a flush with it. Now we will make a constraint to the center of the crane as the lifting radius to be on the lifting radius. So we will make a flush, define the offset as 15 meters. Now for the front of the truck, we will select the plane at the front of the truck and define the offset from the center of the crane. Okay, so let's select the planes by that way, and let's make it flushed instead of mate. Defined the value. So let's select this plane again, select flush, and select the mid plane of the crane. Define the offset as 11 meters with a negative value. And from here, let's add a parameter to control this value. So let's add truck location, the parameter name. After that, we will define the unit to be in meter instead of millimeter. Now we will create define this value from the constraints to make it truck location. Okay, so when we change the value of the truck location, in this case, it will be changed on the real case. Now we will create a new form, and let's add the truck location here, and let's define it as a slide bar instead of values. So the let's define the start value and the minimum and maximum value and the step of a change. Now when we change this, let's make the text above. So let's make it at top, the text above the slide bar. Okay, here as you can figure, the values in meter, so we need to change it again. So let's come back to the parameter and define the values in meter. So let's make it 11 meter and 30 meters. Okay, with 1 meter as a step. So when we try to change it, so you can figure that by increasing the values, the truck is moving by controlling the location of the truck. Okay, by that way we can test the animation before starting with the animation. Okay, now let's import the assembly of the horizontal vessel. From here we will import the horizontal vessel. It's an assembly. We create it including the spreader beam, the shackles, wires, all of that. From view, we will select a view. We will remove all work features like UCSs, planes, all of that. And now we will make a constraint for the equipment itself. We need to get the center of the wire, the center planes of the wire. So we will double click on the crane and select the wire part here. And from here we will check the planes, which is on the middle of the wire. Okay, so we will use those planes on the constraints of the horizontal bezel. From here we will select the mid plane on the longitudinal direction and make it flushed or mate with the wire plane. Okay. After that, we will add two more. We will add two constraints, another two constraints. One of them, which is make it perpendicular to the track, which is by selecting the plane of the wire, the mid plane of the wire. Okay, so let's select this plane, which is work plane 1. Okay, so now it's on the middle of the wire. Now let's define the position of this vessel from the bottom. So from here we will select the base plate to this one and define the spacing, make it on negative value, and from here we can adjust it a little bit to make it suits and make it make sense. After that, we have now the assembly of the is fully constrained for the vessel. Now let's add some parameters to control. Let's say first the project or the assembly. Now let's add a parameter for the wire length. So from fx parameters, let's add the wire length parameter, and let's check the length of this wire. At this case, it's around 20 meters. So let's define the value or edit the value to make it 20 and 100. Okay. And from here, let's add a iLogic rule. And from here, let's select the parameter of on the inside the assembly, which is the wire length, and make it equal the wire length in our final model. Let's add the wire length on the form and make it as a slide instead of text, and define the length of the wire, define the minimum and the maximum value. Okay. And the step of changing the step size. Now let's test this. Okay, we need to make the text at the bottom. So from here we will change the location of the text to the top. Okay, and click OK. And now let's test this. So as you can see, the vessel goes down because the length of the wire is increased. So we need to modify the maximum and the minimum values for the wire. So let's open the editor again, and from here select the wire length, and from the slide we will define change the minimum value. Let's make it for example let's say 10 meters, and for the maximum leave it as it is. So here, as you can figure, now it's moved up. Okay, so let's get the value back to the old value, which is 2100. Okay, now let's add another parameter for the crane orientation. On the crane itself, we have a crane orientation, and let's add in our new assembly another parameter, which is crane orientation. Define the units in degree and define the value in 0. Now let's add it on the rule, iLogic rule, sorry, and make it equal the crane orientation. Let's click OK. Now let's come back to the form and add this parameter here. which is crane orientation, and make it as a slide. All of that to test the animation before going to the Autodesk Inventor render. Now let's make it a top and let's test the orientation here. Everything is okay, so the parameters in that case is okay. Now let's save the project, and from the environment let's change the light, the go to the environment and open the animation timeline. And from the animation timeline, you can change the end time of the animation. So let's make it 60 seconds and let's open the FX parameter and select the parameter that we will need it to make animation. Okay, so from here, let's select the wire length, for example, and animate this parameter. Let's start our animation from 0 to 4 seconds. And from here, let's minimize the wire length and let's click OK. Okay, as you can figure, we select specify to specify the start and end time. So you can figure that the wire length is changed. Now let's add animation for the track location. So let's specify, define it from 4 seconds up to 10 seconds and change the location of the track. Click OK. Now, if you check the animation here, you can find that the animation for each parameter appear here. So we will make some changes for the start and end for each one, like that. You can make a modification by opening this toolbar, and let's make animation. So you can check that the animation for those parameters, it's okay. Now let's add another animation for the crane orientation. So from specify, we will define the start and end, define the end orientation angle 120 degree, and let's click OK. Now if we come back to the first point or the first second and make animation like this, you can figure that the wire length is changed, the track location changed. After that, the orientation of the track will change. Okay, let's add another animation for the wire. Increase the wire length to make the saddle of the horizontal vessel laid on the ground level. So we will measure how much length we will need. It's around 2 meters, 0.5. So from the animation favorites, we will select the wire length and specify from 30 seconds up to 40 seconds. We will change the length of the wire to be 21 meters, 0.5. So let's change it here, 21.5, and click OK. So the vessel will be on the ground level. Okay, if we take a look, now it's on the ground level. As you can figure here, that's the animation playback. Okay, now we will learn how to make a camera and how to animate the movement of this camera during the rendering. So, okay, let's adjust the view as we would like to start our camera view. And from camera, here we will create camera from view. Now we have a camera from this view, and let's animate this camera. We will specify the animation start from 0 to 15 seconds, for example. After that, we will define the animation. And we will link the camera to the second view that we would like to look at it. So that's the end view as the 15 second. Let's change the zoom of the camera. And let's click OK. Now, if we click and select the camera view from here, you can figure that that's the camera, the view from the camera 1. Okay, so the camera itself is moving by defining the location of this camera. Let's click on it. Let's make it 10 seconds instead of 15, and click on OK. Now let's add another animation for this camera. Starts from 10 seconds. So let's start a new animation, and from specify, let's select 20, and from here let's link it to the link view. So select the link view first. After that, let's select the end view at the 20 seconds. So it's okay now. And let's test this. Okay. And let's click on OK. Okay, we get a message here because we didn't define the start time. It's 0. So there is an overlap. So we will make it from 0 to 10, after that from 10 to 20. So we will make it start from 10 seconds. Okay, so the movement of the camera will be like that. Okay, and let's another animation for the same camera from 10, 14, specify from 40 up to 60, and make it around the original axis. So let's make it around Y axis. So make it 25, and let's click on yes. Now the movement will be like that. Okay, if we open the timeline parameters here, we need to modify the start value from 40 instead of 20. So let's make it specify, modify it 40 seconds up to 60 seconds. And the orientation value, so if we take a look from camera 1, it will be like that. Okay, so we need a little bit to change the orientation value. So double click on this and increase, make the orientation on the other side, make the value with half. Okay, let's make it half. Okay, and let's test this on this view, not camera 1. So let's keep the view as it is. So the movement will be like that. As you can figure, the camera target and the camera location appear on the rendering view. On the next step, we will learn how to make it invisible on the drawing area or the 3D model. Now we will, after that, we will test on camera 1. So we will select camera 1 and test with camera 1. So the rendering will use camera 1 like this. Okay. Now we will make the camera invisible on the rendering area. After finishing the rendering, now we have the camera 1. So we will select the camera from the drawing area and right click and make it invisible, or from the tree itself we can make it invisible by that way. Okay, now we have the animation done. And one more thing we would like to say, by using the SEG helper, we will go to the desktop and open the SEG helper. This tool includes some pre-built assemblies for some standard cranes, shackles, transportation trucks. So we will select the mantok and select the shackle, select the truck, and select the location, and create this on our project. Okay, now we already created them. Thank you for your time. Have a nice day. Bye bye. Assalamu alaikum.